Hello friends, my name is Salman and you are watching my channel Untitled Tech. In this video I will discuss what is RAID, why we use RAID, what are the RAID level are there in computer science. So in our basically in our home PC we have only one hard drive. If something goes wrong with our hard drive, for example it goes down or it has some fault, all the data is lost. So in case of servers we have multiple hard drives and we have arranged in a manner to recover our data in case of any fault occur. So this is done with the help of RAID. RAID is the acronym of redundant array of independent disk, or sometimes we call it redundant array of inexpensive disk, because these disks are independent or inexpensive. Data is copied or spread on multiple disks. Because the data is copied on multiple disks, so in case of failure of any disk we recover our data with the help of RAID. If a disk failure happen, no data will be lost. So we will discuss what are the RAIDs, and now I will explain what are the RAID levels. So RAID storage is another very important part of the fault tolerance. Data loss prevention. We use RAID for data loss prevention. There are so many levels of RAIDs, but the common RAID levels are RAID 0, RAID 1, RAID 5, RAID 10 and RAID 6. So first of all I will discuss RAID 0. RAID 0 sometimes called as stripping, because if for example if I have a data A, B, C, D, E, F, G, H, I, J, K, I will strip down it to different chunks. For example, I will spread into stripped across the multiple disks. Yes, in this case I have a 2 disk. I copy some data on disk 1 and some data on the disk 2. So incoming data is stripped down, or you can say we divide it into a chunk and write it down on a different disk. But RAID 0 is not a fault tolerant system, because if a one disk goes down, we will not able to recover any data from the other disk. So this is not used for data recovery or fault tolerance. So if one disk is down, our all data is lost. The second one is called RAID 1. RAID 1 is also called as mirroring or duplexing. RAID 1 is purely fault tolerance system. Data is copied on more than one disk. In RAID 1 we copy the data on the 2 disks. In one disk I write down, I copy all the data, and the other disk is the real image or real mirror image of the first disk. So if something goes to my first disk, because the data is exact the same on the other disk, each disk has the same data. So in case our failure of any disk, we can recover our data from the working disk. So this is called RAID 1 or mirroring or duplexing. Now we move on to RAID 5. RAID 5 is also called as stripping with PARITY. Basically in RAID 5 we need to have at least 3 hard drives or more. Data is stripped across multiple disks along with a priority. In RAID 5 we strip down the data along with a bit which is called priority. The priority bit is used for recover any data in case of failure of any hard drive. So in the equivalent of entire disk used to priority. For example, if we have 4 hard drives, the one we have only available disk for 3 disks. For example, if an array of 4 disks totaling of 4 terabyte, only 3 terabyte will be used for actual data, and the remaining one is used for the storage of priority. So if something goes to one disk, then we easily rebuild our RAID and get back our old data. So RAID 5 can handle only the single disk failure. If we have a failure of 2 disks, we don't able to recover our entire data. So it is only tolerate the failure of one disk. Data is across the multiple disks with priority. So if in case of one disk failure, we can join another disk and the data rebuild itself. And in case if we have a failure of 2 disks, what will happen? Then our old data is lost. So we don't able to recover our old data. But in real scenario, in my life, in my experience, 2 disks at a time is not an easy task, or a very rare time. In my life, I will see that 2 disks fail at the same time. So to recover this type of failure, we have a RAID 6. RAID 6 can handle the 2 disk failure at a time. For example, in this example, if I want to create a RAID 6, that means I need to have at least 4 disks or more disks. In this case, priority is spread twice only all the disks. So in this case, in RAID 5 we have priority on single time on each disk, but in RAID 6 we have a priority twice as compared to the RAID 6. So RAID 5. So in case of 2 hard drive fail, we can recover by connecting the 2 hard drive, and the data is recovered, rebuilt in case of RAID 6. So in RAID 6 the equivalent size of 2 of these disks are actually used for store data, but the disadvantage is that if we have 4 drive, only 50% of data hard drive is used for storing data, and 50% of use for priority of the hard drive. So this is the very consuming our hard drive spaces. The equivalent of 2 disks are used to store the double priority. The read performance of RAID 5 and RAID 6 about the same. The read performance is same, but the write performance in RAID 6 is slower than RAID 5, because it has to write 2 independent priority blocks instead of 1. So now finally we have a RAID 10. Basically this is the combination of RAID 1 and RAID 0. As you can see, I have a combination of RAID 0 and RAID 1. In RAID 0 we have to write, we have stripped down our data into 2 different strips. For example, as you can see, we have 2 groups of this one and this 2 is group 1, and this 3 and this 4 is a group 2. In RAID 0 we have write down different data. As you can see, in group A we write down A, and in group B we write down B. Similarly C and D, E and F. Now in RAID again we have 2 disks mirroring each other, so that same data is write down on disk 1 to disk 2, and same wise disk 3 to disk 4. So in this way we can have the speed of RAID 0 and the safety of RAID 1. So benefits from take the benefits from the fault tolerance of RAID 1 and the speed of RAID 0. But in this case, in RAID 10 configuration we have only 50% space usage for our data. For example, in my scenario I have a SAN which is 100 terabyte, and I configure it into a RAID 10 configuration, and after that I have only the usable storage is 50 TB. So we can only use 50% of data storage of our whole capacity. So in my opinion, that RAID 5 is good enough, but if you have a very critical data like your database servers and your application servers, you can configure your RAID level like 6. So 6 is very secure, because it can tolerate up to 2 hard drive failure, which is occur very rarely. I never seen in my life except one time when the 2 disks fail at the same time. So if you like this video, then press the like button, and in comments write down to me which RAID level you are using in your data center or your server rooms in your servers. Thank you very much for your time, and see you again in a next video.